Hello, this is the weekly update from Mr. Fix's science class for the week of August 26th. Okay, so on Monday we continued the soda can. We actually recorded the data, temperature data, and I'll show you that in a little bit. On Tuesday we did math testing, so that was all day long. All right, then on Wednesday we finished up the soda can and analyzed the data. So let's take a look at that. So again, the soda can is all about the phenomena that cold soda gets warm over time. So the problem I'm trying to solve is how do you keep the heat energy from the can surrounding from going into the can. So we wrote down a couple of heat transfer key terms, heat and thermal energy, into page 8 of the reference notebook because we're going to use that in this activity. Experiment time, we had water placed into 6 soda cans and they were covered in different materials wrapped around them: felt, foam, construction paper, plastic, aluminum foil, nothing. They were in the fridge overnight, and they had to predict which material is best at preventing heat energy from getting into the can. Again, this was all done in the Doing Science notebook. So experiment time, we collect the data every minute, the temperatures of the water in the cans for every minute. We're up to probably 25, 26, 27 minutes. So we look at the data table, and the data table is very overwhelming. So instead I took the data and I displayed it into a graph, a line graph showing the temperature of the water over time. And so I asked them, hey, look at the trends. And the trends they should notice is basically the temperature increased in all the cans. Now, it's very hard to tell, well, which temperature increased the most, which is the biggest temperature change. It's hard to tell by this. So I took that data and I calculated the percent temperature change. So regardless of what starting temperature they were, so they all started at different temperatures basically, we took that in consideration, and instead of just the overall temperature change of the can, we did percent temperature change, taking into consideration, again, they had different starting temperatures. So now what they did is we looked at, well, which one seemed to be most effective at reducing temperature change, which one's least. So for this period 1, the least effective material was construction paper and the most effective was felt or foam. Again, nothing is what normal conditions, there's no wrapping around it. And so this is period 2 data, this is period 3 data, or period 2, period 7 data, and then period 8 data. And then in their Doing Science notebook, they had to answer these 4 questions, and we went over them in class. Then we continued writing down the heat transfer key terms on page 8 of the reference notebook. We actually finished it this week. We finished it up on Thursday. So we have thermal energy, temperature, heat insulator, heat conductor, and then types of thermal energy transfer: conduction, radiation, convection. So again, this is on page 8 of the reference notebook. And we storyboarded the cold soda reference notebook on page 9. So if we take a look at that on page 9, we try to explain visually, we try to tell the story of why those percent temperature change happens. Basically, it had to do with the amount of thermal energy flow that was going in there. So the more arrows, and one arrow represents a certain amount of thermal energy flow. So the more arrows are, the greater the amount of thermal energy that was flowing into the can from outside, because that was the higher temperature area was the outside, inside was the lower temperature area. So heat, one of our key terms, is that thermal energy moves from the area of higher temperature to an area of lower temperature. So that was storyboarding on the top half of page 9. Then we did a tray temperature. So tray temperature, I took 2 trays out of the refrigerator that had been there for a while. One was metal, one was plastic. They felt with the same hand the surface of both those trays, and they figured out really quickly that, the metal tray feels colder than the plastic tray. So then I asked them, well, is there a temperature difference between them? And so they said, mostly, yeah, metal tray should be colder or lower temperature. But in fact, they were the same temperature. So I get them thinking about it. So then we did a spoon race. Spoon race involved a plastic spoon and a metal spoon. And we placed ice cubes on both of them and see what happens. And so the one on the metal spoon melted faster, and some people noticed that this metal spoon felt slightly cooler than the other one. And so we're trying to figure out, well, what's going on there? So on page 9 of the reference notebook, we visually told the story of what was going on. So basically, metal is a good conductor, so lots of thermal energy was flowing from the hand to the metal spoon to the penguin to melt it, and that's why your hand was getting a little colder. Whereas plastic, not such a good conductor, so less thermal energy was flowing from the hand into the penguin to melt it. The penguin didn't melt much at all in the plastic spoon. So that was that. And then we did an activity today, Friday, Ice Cold Lemonade. They had the situation where they had to read it. They had to choose a response that they agreed most with it and explain it. And they practiced their posing questions, pausing, paraphrasing. And some chose A, some chose B, some chose C. The correct answer was definitely B. And again, we're trying to reinforce the idea that thermal energy always flows from an area of higher temperature, which was the warm lemonade, to an area of lower temperature, which was the ice cubes. And that's why the ice cubes melt. And then we finished temperature versus thermal energy sim. So this was a Schoology assignment. So they used the sim and Amplify to answer these questions. And basically the whole goal is to figure out what is actually the difference between temperature and thermal energy. So temperature is the total energy of motion of the atoms and molecules the substance made of, whereas temperature is the measure of the average energy of the motion of the atoms and molecules. So it's like, well, that's hard to understand with just those words. So we actually did activity sim where we saw these molecules actually simulated and what happens to the energy of motion, the kinetic energy of these molecules when different levels of thermal energy are applied to it. And we saw thermal energy levels and temperature levels and what happens with them and so forth. So we're going to go over that. We did it, we turned it in on today, and then on Monday we're going to go over it. All right, so that is your weekly update for this week. Hope you have a good weekend. Bye-bye.